right? So folks, this is the Francis Carroll stone here, okay? And if you wanted to plot the sun on its journey around the earth for a year, you'd blank that there. You'd put the eye of the harp in there. So it'd only be a turn off a bush. You just make a pinhole, that's your precision. You'd put something behind here, and then at noon every day, you'd mark the point of the sun on that. And the shape that you get out is on that stone directly south of us there. That's the analemma. So, and I'll show you the shape of that there. Look, we go around there. That's the shape of the analemma. There, look. You see it there? And all what that tells you now, okay, is there's your analemma, look. So that's your sundial. It's also, there's your winter solstice, there's your summer solstice, there's your equinox, there's your equinox. So they now had a map of the sun going around the earth. They didn't have to look at it anymore, no. They could now predict things because they had a calendar now where they knew where the sun was always going to be. And it's like a navigational guide as well. So it's called the analemma, but it's also a sundial. So that's what they were doing here at the Francis Carroll stone. So if we move along this way now, we're going to go over here to the Ranna Crumdove. Oh, my tape measure. My tape measure's in the bag behind there, Fiona. I have to start at the end. So folks,
Will I hold it?
Please, yeah. So folks, this is the James Stephen stone. This is the Ranna Crumdove. That's 101 inches high, and from there to there is 101 inches, and that gives us a square. And if you have a square, the next thing you can do then with a square is you can turn the square into the golden rectangle, and you can construct the golden spiral here, look. That's where you construct the golden spiral around like that. And you might think, but how could they really do that? In order to construct a golden spiral, you'd need the squares of all of the parts of the spiral. And you see these marks on the stones here, look, see them stones? They left all the measurements of the squares for us to construct a golden spiral there. And the series that we know that today is as the Fibonacci sequence, but it's been here since about 40, it could be 100,000 years. We've had it here for ages. So
Fibonacci is the Renaissance.
Yeah, yeah.
This is way before.
Yeah, yeah, Fibonacci is the Renaissance, only what, 200 or 300 years ago? That's probably it. So we had that here. Now there's a very important measurement here. Look, turn on there's a carved edge here, folks. Could you hold that on there, Fiona, for me? You see that measurement there, look? That's 69 and 5/8 inches exactly. Right, see the carved point here? They left the carved point here and they left the straight edge over there. And if you subtract that 69 and 5/8 inches from the total distance across there, which is 101 and an eighth of an inch, you get 114 exactly. So if you want to position this circle from the equator, way down there, you need the number 114 to do it. But you'd also need the inverse of the golden number, 360 degrees, and pi. And where would you get 360 degrees in the circle? If you add the inside diameter there, it's 150, to the outside diameter is 210. That's where you get your 360. And you get your pi. There's an outlier stone over here. That's 330 feet from the center of the circle. The radius from the center of the circle to the edge of the is 105. If you divide 105 into 330, you get 3.14 exactly. That's what they left here. Now, in order to find pi here, you would have to divide 105 by 15 and 330 by 15. That gives you 22/7, because these people worked in fractions as well. It's a lot easier to work in fractions than it is in decimal. So you work in fractions until you get close to what you're getting at, then you go to decimal. So that's how it's done. And 22/7 gives us 15 here. So they showed us 15 here. So what would 15 be? 1 hour of time of the day is 15 degrees. So they knew what time was here, so they knew everything here.
Jerry, could I mention one thing?
Yeah, get close to the mic there.
If you were trying to communicate with someone 6,000 years in the future, how would you do that? Because you don't know if they're going to be speaking English or Irish or what. So they're talking to us through the millennia using mathematics, because mathematics is the universal language. 1 + 1 = 2, no matter where you are in the universe. So that's how they're able to communicate with us today from thousands of years ago. And thanks to the work of Jerry and Billy, they're bringing back all this knowledge, because it's in the stone circle in the measurements, because the maths don't lie. And you know, you can write something down, but over a few hundred years the text will be destroyed. But they wrote it in stone, so it's here, and it's built with the embankment. So this stone circle has survived so long because it's so well built. And you know, that's what I feel Jerry's work is so valuable. We're able to communicate with these people like through thousands of years, and that's the beautiful thing about this work, you know. That's how they communicate with us today and share their knowledge.
So there's a trinity attached to the golden number. So this is 38 and 5/8 inches across here, okay? And if you divide that into the width of this, you get the golden number. If you add the two of them together and divide by that, you get the inverse of the golden number, which is 0.618. And you can also get 2.618 out of here. What else was there about that? So
the clock and clash is important. That's
so
stone.
so you can see when you do the two golden spirals here, you end up with the mitre. When you join up the pertinent points of the golden spirals, you get the mitre, and right in the centre of the mitre is the triangle, and that's a 40-degree angle, and it's very, very important. And right in the middle of the triangle is the clock and clarsig. So Billy, would you like to say?
Well, the clock and clashing is so important. When Cromwell camped his troops here, his son-in-law Ireton was in charge, and he they defaced all the stones because all that knowledge was on these stones. And there's two stories about that. One is that the local people brought it to the lake and hid it in the lake, and the other was that they put in another stone, and that's what Cromwell broke. He broke the stone. You can see it there, look. But that's the original harp stone. But that's what Cromwell, Ireton, he broke. They didn't want all that. They took all this knowledge for themselves, for their empire, and that's where it all comes out of. And I think it's important that we know. I heard them today talking about praising Cromwell. They shouldn't have been here, because all they were interested was for the food, to feed their crown forces and the Royal Navy, and our people were starved to death. And I think all we can do is ask for accountability, that will never happen again. You're sovereign people, and that's what the 1918 32 county election, which you never hear of anymore, and that's what your sovereignty. You own that. Even if they come and take your house, you might have borrowed money and you can't pay it back. Let them take brick by brick, slate by slate, but you own that land. That's yours, because you're the sovereign. And that's what I think is very important, what our ancestors did here. And that goes back to 1155.
Billy, when Cromwell was here as well, he sent an edict that all the harpers would be killed, specifically the harpers, that their instruments would be destroyed. And I don't know if this is true, it's a hypothesis, but if I was to play harp, this stone right here is perfectly level. This is movable, this isn't
Yeah, you can take that off. I take that off. We've had harpers sitting on that playing the harp.
So I might take this off, if that's alright.
Oh. Want a bit of strength?
Anna.
So that's where they put the harp, isn't it?
Yeah. And the harpers would sit there and look at people still today. Look, there's the coin.